All right, so we're recording now. So if you don't want your true background recording, then take it off. And let me start to share the screen and so on. Okay, so I won't lecture the whole time, obviously. I need to give you time to do the quiz. So you've already seen one quiz, so you know all the quizzes are pretty much the same. Okay, so I'm already in the 1.5. So there's a good chance I'll finish fairly early. I'll sneak in some of calculus, chapter 2, ahead of time. For exams, so I'll tell you ahead of time, Thursday, I will devote the entire time, at least I'm planning to devote the entire time for question and answers. So if you have any questions about anything from here, bring it up. If you haven't already done so, start developing your formula sheet, your cheat sheet. Okay, 1 8.5 by 11 sheet of paper, both sides. Put anything you want, any formulas, any sample problems, that would be okay. Okay, and then you have to submit the homework. You know what the homework is. Okay, I do have a 70% requirement, which means if you don't submit at least 70% of the homework, I don't grade your exam. Okay, it's not that hard to do considering I end up doing what, 25%, 50%, something like that. So you just have to do the rest of the problems. Okay, and let's see. So on exam days, right a little bit after 9 o'clock, I will send the exam via Canvas announcements. So look under Canvas announcements, but I'll also project it. For some of you, it may be better if I project it. So I'll get both ways. And then you just work the problems out in class. The problems are very similar to the homework. Just pen and pencil, work it all out. Then you have until 10 o'clock. I close the class at 10 o'clock as usual. Then I'll give you 5 minutes until, what, 10:05. Just click, 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 take pictures on your cell phone and submit it to me by 10:05. Then I'll let you have until 10:30 to submit the homework. Although if you want to submit the homework early, I'll let you. So let's say after class on Thursday, if you want to turn in your homework anytime between after Thursday and Friday at 10:30 a.m. would be okay by me. Okay. I do want to warn you, I've noticed in the past, sometimes doing all the homework, it doesn't fit in one email. Okay, I got some messages like, oh, this file was too large or something like that. So it wouldn't all fit for some of you. So maybe one strategy is give it one section at a time if that doesn't work. So send me an email for 1.1 and another one for 1.2 and so on. But if you want to do it all in one fell swoop, that's fine. Or maybe you can fit 1.1 to 1.3 in one email, and then 1.4 to 1.5 in another email. As long as I get the whole thing, that's going to be fine by me. Okay. So that's the way exams will work. All right, so I'll do some problems. Feel free to put stuff in the chat. I'll get to it later, or if Prasanna can help you, that'll be fine also. Okay. So let me start off with problem 18, which was an even one that I didn't do yesterday. And again, sorry, I can't write and show this to you at the same time, so you just have to listen for the answers. So 18 was assigned, right? Okay, so again, as much as possible, whenever I give you an even problem, I'll try to do it in class. I end up doing a lot of the odds also anyway, but I especially owe you the evens because you don't have those answers. Okay, 18. Why is the graph 1 to 1? Well, it passes the horizontal line test, right? So if you draw a horizontal line anywhere, it's going to touch on only 1 point. Okay, let's make the assumption this graph stops. It might seem like it goes on, but let's assume it stops. It doesn't go on. Okay, whoops, I seem to have gotten some strange mode there. Okay. Okay, B, what are the domain and range of F inverse? The domain and range of F inverse are the range and domain of F. Okay. So look at the graph. I can't point it to you, but we're doing 18. The domain looks like bracket -3 to 3, right? The extent of X. So that means the range of F inverse is bracket -3 to 3. Okay, I can just barely get this. Okay, so the domain of F is bracket -3, 3 with brackets. That's the range of F inverse. Right, remember, the domain of one becomes the range of the other. And then the range of F inverse is the domain of F. Okay, so let's see, what's the range of the original function? The range of the original function is bracket -1, 3. right? That's the range of f. So that's the domain of f inverse. Okay. Basically, just take the domain and range of f and switch them. All right, now how do I do C and D? If I didn't see the -1, right? If you don't see the -1, it just says f of 2. You know that means x equals 2, right? Likewise here, if you see f of 0, that's x equals 0. So what about if you see the -1? Well, it can't mean the same thing. It can't be x. So if it's not x, what do you think it is? It's y. Okay, so for C and D, you let y equal that value and come up with the x. Okay, so for C, f inverse of 2, let y be 2, which is right here, and that means the corresponding x would be 0. So the answer to C is 0. And notice if you did not have a one-to-one function, you might have more than one value, which means the inverse would not have a function, right? Because then there might be two possible values. D, estimate the value of f inverse of 0. Okay, so y equals 0, and I can see why they say estimate, right? Because it doesn't look nice. So it's over here somewhere. So what do I want to guess? -1 point, a little bit more than halfway. So how about -1.6, -1.7, something like that would work? Okay. All right, so that's 18. All right, so let's see, I did 22, 24, 26 for you, and I gave you something like that as an in-class assignment yesterday. Let's do some more of those. Okay, let's see, 29. How about I do 29 for you? In 29, I'll just have to talk about it, and it's up to you if you want to write it in your book. The easiest thing is to write in a book. I know some people don't like to write in a book, especially if you have to give it back or, you know, give it to somebody else. But here's the easiest way to graph f inverse. Okay. Just take these nice points and switch them around. Okay, so this is the point -1, -2. Switch it around, -2, -1. So put a dot right there. I'm not really going to do it because I don't want to mess up my book, but that's the idea. If we were meeting face to face, I would show this on the whiteboard and project it on the whiteboard. Okay, this is 1, -1. Switch it around, -1, 1 would be over there. This is 2, 2. Switch it around, it's still 2, 2. And that's still going to be 3, 3. And then I just connect the dots. So it would go like that, and like that, and like that, and like that. Okay, so if you want to just put in your notes, just switch around every x and y value. Okay, so -1, 2 becomes -2, 1. Let's see, 1, -1 is -1, 1. That's over there. And then 2, 2 stays 2, 2, and 3, 3 stays 3, 3. So that's the graph of the inverse. Okay, that's all. Okay, 31. Let f of x equals square root of 1 minus x squared. X is between 0 and 1. Find f inverse and identify the graph and explain your answer to part A. Okay. F of x equals square root of 1 minus x squared. X between 0 and 1. Okay. By the way, if I plug in a number between 0 and 1, then this is positive, right? So we're basically in the first quadrant. Okay, so call this y. Y equals radical 1 minus x squared. Switch them around, right? Like we did yesterday. X equals square root of 1 minus y squared. Solve for y. Square both sides. Raise it up a little there. X squared equals 1 minus y squared. Add y squared. X squared plus y squared equals 1. Huh. Before I go on, do you recognize that? That's our famous unit circle from trig. Circle center of the origin with a radius of 1. Right? Anyway, keep going and solve for y. Subtract x squared. y squared equals radical 1 minus x squared. Take the square root. Everything is positive from the original, so I don't need a plus or minus. So the inverse function is radical 1 minus x squared. Okay, so one more time. Switch around x and y, square both sides, solve for y. Add y squared, subtract x squared, square root. Okay, the problem's done, but how does that compare with the original? Same as the original. So here's an example of a function being its own inverse. Okay, and if you stop and think about it, that makes sense from the graph. Okay, so we have the unit circle. This means we're only in the first quadrant. So just have that. So here's the graph of f. And because of the symmetry, you can tell if I reflect across the line y equals x, right? Remember, the inverse function is a reflection across the line y equals x. If you reflect across the line y equals x, you get the same thing back, right? This reflects over to here. This reflects over here. So here's a case of a function being its own inverse. That's all. Okay. All right, then we have some practice with logs. So 35 to 42 all. Okay, so I guess try to do as many evens as possible. Try to remember how we did logs. Okay, 36a, log base 5 of 125. That's the way the problem starts. Okay, so whenever you get something like that, I like to call it x. So call it x. Excuse me. Okay, then you unscramble it, write it without the log. You go 5 raised to the x power, then you come back in for the result. Okay, so again, base, other side of the equal sign for the exponent, 5 to the x, come back in for 1 over 125. Raise it up again. Okay, so now I'm going to try to solve that. Since this is a base 5, I'm going to try to write this with a base of 5. Okay. Now I know that 1 over 125 is equal to 125 to the negative 1. Now 125 is 5 raised to what power? It's 5 cubed. 5 times 5 times 5 is 125. Okay, and now I have a property of exponents that says I can just multiply these two. So 5 to the x equals 5 to the negative 3, and this is what I want. Once I get an equation like this, where this base matches this base, then these exponents floating up here have to be equal. So x is just equal to negative 3. Okay, so in other words, log base 5 of 1 over 125 is equal to negative 3. Okay, b, ln of 1 over e squared. Okay, I see the ln and the e. So the trick is to write it so that the ln and the e are next to each other. Either ln and then e, or e and then ln. If I can get the ln and the e next to each other, they'll cancel out. Okay? And the way to do that is to notice that 1 over e squared is the same as e to the negative 2, right? 1 over e squared, e to the negative 2. And when I write it like this, then the ln and e just cancel out. You just have negative 2 left over. Okay. All right, yes, I see some of you put something in the chat. I can't get to it now unless Prasanna can get it for me. Okay, 38. E to the negative ln 2. Okay, e to the negative ln 2. Now, if that negative sign weren't there, right, then I would just say, oh yeah, e to the ln 2, e and ln cancel out, the answer is 2. But there's a negative 1 in the way. How do I get rid of that negative 1? I make it rise up, right? One of the properties of logs is that if you have a coefficient in front of the ln 2, you can make it climb back upstairs here. So it looks like e to the ln 2 to the negative 1, right? Property of logs. It works both ways. If you have an exponent here, you can bring it down in front, or if you have a coefficient, you can make it climb back up. Okay, so it's e to the ln 2 to the negative 1, and now the e and the ln can cancel out. So I just have 2 to the negative 1, which is 1/2, and there we go. Okay. Okay, B looks bad. It looks like it's dizzying, but it's not so bad when you stop and think about it, because E and ln get to cancel out. E to the ln E cubed. Okay, now, at first glance, again, you say, I'm confused. I don't like all the E's and ln's. Okay, just think of order of operations. Okay, order of operations, what am I supposed to do first? Well, the parentheses. So don't even look at this, right? You got to look at this anyway, and you can't mess with this yet. So just look at this. You know, there's too many E's and too many ln's. Don't look at the whole thing. Just look at this, ln E cubed. Aha, ln and E back to back. Knock them out. So this is just 3, right? That's not that bad. Now that I have that as 3, I'll go back and incorporate the rest of it. So I have E to the ln 3. Perfect. E to the ln 3, E and ln next to each other cancel out. So I just have 3. Okay. All right, moving on to 40. Okay, they want you to write it as a single log. All right, ln B plus 2 ln C minus 3 ln D. Write it just with one natural log. Okay, all the coefficients climb back up. So there's nothing in front of here, so don't worry about it. Or you could also think of this as a 1, which means you can make the 1 climb up, which means you don't have to do anything. Okay, 2 climbs up, 3 climbs up, ln B plus ln C squared minus ln D cubed. Okay, and yeah, you've already seen the answer. Okay, but now you write a single log B. Since this is a plus, can you think what we do? We multiply these. And there's a minus, so we divide. So there you go. Ln of B times C squared divided by D cubed, right? Plus means you multiply them, so B times C squared. Minus means you divide. So there it is, ln B C squared over D cubed. And that's my final answer. Okay. Okay, 42, A and B are very similar. Okay. Evaluate the log for 6 decimal places. So this is a change of base strategy. So I'll just do one of them. Okay, log base 5 of 10, log base 3 of 57. I'll just show you one of them. The other one works completely identical. So the change of base rule says when you have log base 5 of 10, you can just do ln of 10 divided by ln of 5. So it doesn't matter what the base is. ln of the number on top. See, this looks a little bit higher than that, right? The 10 is higher than the 5. So you just go ln of 10 divided by ln of 5. And you just punch it in calculator. So ln 10 divided by ln 5. 1.430677 to 6 decimal places. Okay, so that's all. And a quick word, okay? Do you think I'm allowed to cancel the ln's? Like cancel ln? Well, if you could, you would have 10 over 5. What's 10 over 5? 2. Not the same thing. So there's no law that says you can cancel out the ln's. Right? All right, I'm not going to go that much longer. Okay, maybe I'll just stop at 47. Make a rough sketch of the graph. Do not use a calculator. Just use the given graphs and transform them. Okay. So let me do 47. I think that's good enough. Yeah, maybe I'll stop after that. It's about 9:35. I'll give you enough time to do the quiz. Okay, so I would have been able to finish all the way up to here. I still have all of next week. Okay, so I'll probably take maybe Monday. I might finish on Monday, but maybe Monday and Tuesday to do this. I'll get started with some of the next chapter. And again, Thursday, I'll devote Thursday to the questions and answers. So if you have any questions, bring it up on Thursday. Okay, log base 10 of x plus 5. Okay, now all the log functions tend to look something like this. So a very rough sketch. They all go through 1, 0. Remember that the exponential functions all go through 0, 1. So this one goes through 1, 0. Log base 10 of x. And the asymptote is the y-axis, which is x equals 0. And what does this do? This moves the graph 5 to the left. So here's all you have to do. Just move this key point 5 to the left. So if I was at 1, 0, 5 to the left would be negative 4, 0. So just draw the same thing. Y equals log base 10 of x plus 5. And the asymptote moves over 5 units also. So it used to be the y-axis, which is x equals 0. Move it 5 to the left, and I have x equals negative 5. So here's my graph. So y equals log base 10 of x plus 5. 1, 0 moves to negative 4, 0. And the asymptote is now x equals negative 5. Okay, I do see a lot of stuff in the chat, so I want to get to that. Unless Prasanna already got it. We'll see. Y equals negative natural log of x. Okay. So again, natural log, which is log base e, all the log functions tend to look the same. So what I have in blue is a natural log function. Okay. And what does a negative do? Negative, you might recall, reflects across the x-axis. Okay. Now, since it crosses, it might be hard to see the whole thing at once. If it's hard to see the whole thing at once, just put it in pieces. Okay. If I only look at this part, okay, you can say, oh yeah, the reflection across the x-axis is this. And then if I only look at this part, then you see this, right? Then you can say the reflection across the x-axis is this. So there's the whole thing. Okay. So if you can't see the whole thing, don't see the whole thing, just take them in pieces, maybe split it up right into this and say, okay, if I reflect, I get that part. And if I reflect, I got that part. And there we go. Okay. All right. I was going to stop there. I was going to maybe do some more, but I do see a lot of stuff in the chat. So let me check the chat real quickly, please. All right. So let me try to go back up. Okay. So yeah, it's mostly I was frozen. I'm not sure if I'm frozen now. The test will have about 10 questions. I tend to give about 10 questions. -1, I think that's what you mean. But yeah, if you mean over here, now 1 over 125, I want to write this so that the 125 is upstairs. So 1 over 125 means 125 with a -1. Okay. So if I was frozen, sorry if you didn't catch me. I'll check the video, but maybe that's frozen too, but nothing I can do about that, I guess. Will there be problems that need to use a calculator? For sure, you're allowed to use a calculator. But, just like give to 6 decimal places. So you punch out ln10 divided by ln5 and stuff like that, right? And I think I'm caught up. Most of it was that I froze, I guess. I'm not sure if we got everything. Okay, so since I was frozen and I'm not sure what got frozen, maybe I'll just project everything I did again quickly and you can look at the video. So maybe you didn't catch the talking, but, let's see. Where did I start? Yeah, I started from here. Okay, so let me just kind of go back and forth here quickly so I can give you time to do the quiz, in case you didn't get any of this. And all that. I might be going fast, but you can check the video later. Okay, that's as much as I'm going to do. Okay. Let's see, I froze before going over the problems. Okay, then I'm guessing that means we're okay. Well, we'll check it out. We'll check the video later and go from there. Okay, any other questions? Otherwise, we'll go straight to the quiz. Everybody get your cell phones handy, or if you know how to do a screenshot, you can do that. And then get started with it. I'll put you in your breakout rooms. Again, it's up to you if you want to, show your face or not. I personally think it's just weird to talk to somebody and you can't even see them. Okay, so once we start, put your first and last name, Put your teammate's first and last name. Okay, if you finish early, you can leave. And then it's due at 10 o'clock. If you finish early, you can send it early. I'll close the class at 10, and I have to get it by 10:05. Just email it to me, and so forth. Okay, so here we go. I'll hold it for a few seconds. Composition problem. F of x is x squared minus 5x. G of x is 4x plus 14. Determine f of g of x and g of f of x. And simplify as much as possible. You can see there's a square there. So if you have a chance to square the expression and clean it up, then go ahead and do so. Okay, so f of x equals x squared minus 5x. G of x equals 4x plus 14. Determine f of g of x and also g of f of x. Okay, if you finish, don't leave. You got to get all your teammates' members to get it correct also, remember. Put your first and last name, all your teammates also. You don't know which one of yours I'm going to grade, so the only way to be safe is to get everybody else in your team to get it correct too. That way it doesn't matter which one of you I grade and you all get the same grade. Okay, I'll hold it just for a few more seconds and then I'll assume you all have it. Okay, so if you got to go ahead and get started, but give me a minute to set up your breakout rooms. So x squared minus 5x for f of x. G of x is 4x plus 14. Find f of g of x and g of f of x. Okay, I will now assume you all have it. Okay, I'll stop the share. So go ahead and start working. I'll stop the recording also.